Hello guys, welcome to another topic presented to you by the Visionary Society of Engineers. This time we present to you shift register and we'll explain how it works, alright, the application, and how can we utilize it within electronic system. Okay guys, so what is a shift register? Shift register is a type of digital circuit using a cascade of flip-flops where the output of one flip-flop is connected to the input of the next. They share a single clock signal which causes the data stored in the system to shift from one location to the next. By connecting the last flip-flop back to the first, the data can cycle within the shifters for extended periods. And in this form, they were used as a form of computer memory. In this role, they are very similar to the early line memory system and were widely used in the 1960s and early 1970s to replace that form of memory. So as far as registers is concerned, it is primarily used for data entry operations, such as keyboard input that is required to be processed and displayed on a screen. When it comes to shift register, we can also use it for binary to decimal conversion, especially when we need to see the number displayed on the screen. Right? As you know, the data that is inputted to the register is in the form of bits and zeros. However, in order for us to display it digitally on a computer screen or perhaps on a calculator screen, we can also use a segment display in the conversion process, where that digital data is being converted in a form of a decimal. Right? So that is how effectively registers can be used in the conversion process. Okay, so shift registers are used primarily for temporary storing and holding data for arithmetic and logic operation within a central processing unit. Alright, so in terms of how computer works and how it collects the data and storing and holding and carrying out the computation process. Alright, so the registers makes it very easy for this operation to take place. Okay guys, so when it comes to type of register, there are serial types and there's parallel type register. Alright, for the serial type register, the register is going to allow the data to input serially, and for the parallel type, individual inputs is allowed to enter the register at the same time. Alright, so that's a different sequence of how the registers are processed. So there's a serial register and there's a parallel register. Okay guys, so as far as registers are concerned, there are common register configuration type, and that is a serial input, parallel output, and parallel in, serial out. Alright, and finally there's another one which referred to as a serial in, serial out. Alright, so these registers are configured in a way based upon their application. Hey guys, look at this once again. Shift registers, as it is, are basically a types of sequential logic circuit used to store and shift transfer data bits either in serial or parallel or combinations of both serial and parallel. So they are basically configured using the flip-flop in sequence where the output of one flip-flop becomes input to the other. So the flip-flop makes an ideal choice in designing them as they are edge-triggered devices and can obtain or rather retain output state. Okay guys, looking at a serial input parallel output register, we have data input pin and a clock pin, and then we have 4 output pin. All right. Some register may show up to 8 pins, or it may use up to 16 pins, depends on the operation. All right. So this is just an example of a serial in, parallel out register. Okay guys, so now look at the parallel in serial out register, where we got 4 inputs to the register, and these values going to stored within the flip-flop. Upon the signal being reached by the clock, then it's going to move sequentially out of the flip-flop, right, through our output pin Q. Right, so this is how it designs when it's a parallel in serial out register. Okay guys, so look at the shift register in operation. We have a data pin, we have a clock pin, and we have a data latch pin. All right, so these pins are what define the operations of the shift register. All right, so when the data tries to enter upon the first bit, it requires a clock input. All right, so when that first clock input is triggered, then the data is shifted into the register. All right, and it reads until there's another trigger of the clock along with the data being transmitted for it to move another data within the register. All right, when a maximum of 8 bits is achieved, then a storage pin is used to transfer the data, all right, to the storage register. All right, and that is where it is recognized at the output of the Q pin. So that is how the shift register works to produce the output at the Q point or the Q pins. Alright, looking at the operation of a shift register, we can see that it comprises of 3 segments: shifting within the register, storage, and output. So the first segment requires the data to be inputted to the register, and that is when we use the data input pin and the clock pin. Alright, so for the data to be entered or shifted within the register, it requires the clock acknowledging the data pin. Alright, so upon acquiring 8 bits within the register, then that value is ready to be moved out of the register for storage. So that is when the storage pin, right, is acknowledged and the data is shifted out of the register into the storage register compartment. All right, and then that value that is stored can be enabled to an output that is via Q1 to Q8. All right, so that is the sequence in which the register collects the data, store it, and output it for display. Okay guys, so looking at the register here, SM74HC595N, very common form of register. Alright, this one can be used for both serial in, parallel out, and in case you can also use as serial in, serial out. Alright, so this comprises of 16 pins. 8 of these pins are used for the data output of the parallel serial in, parallel out. All right, and the other pins are used for various functions for the register, whether it want to be the voltage, VCC, or data input pins, and enable pin, clock pin, etc. All right, so this is a physical display of the shift register. Alright guys, so we're gonna explain shift register 74HC595. Alright, so the first pin on this register is pin 14. So pin 14 is responsible for sending the data serially. And we're gonna look at the following pin, which is pin 11, which is a clock pin. The clock pin works alongside with pin 14, and it is responsible to provide the trigger for each bit of data that is to be sent to the register serially. So it tells the flip-flop or the high Cs when you have finished transmitting one bit of data. It allows one bit input serially to process into an 8-bit registered output. And then, after which that 8-bit is registered, then it's ready to be transferred. So the transfer of those 8-bit output, it is acknowledged by a storage pin or a latch pin. All right, so this pin is responsible to store or hold the data when a new set of 8-bit is attained. And then we have pin 13, which is an disabled output of the register. All right, so you can use this pin to provide a display of the value of the 8 bits that is being stored. All right, so this value you can be displayed from the register, or it can be disabled. All right, so the next pin we're going to talk about is pin 10. Pin 10 is a memory reset pin, and it is used to clear the data from the memory. All right, guys, so we're going to look at the other registered 74HC595. All right, so this comprises of a ground pin, pin 8, which is used to establish a grounding potential for the chip. And then we're going to look at pin 16, which is the power supply to the pin. All right, a minimum of 5 volts. All right, this pin is otherwise called the PCC pin. And then we have the data pins, which is Q0 to Q7. All right, so Q0, which is defined by pin 15, and then we have Q1 pin 1, Q2 pin 2, Q3 pin 3, Q4 pin 4, Q5 pin 5, Q6 pin 6, Q7 pin 7. All right, and finally we have pin 9. All right, so for the shift register 74HC595, we have a pin 9, which is a serial data output pin, which is called Q7. All right, with that inverted or squiggled. Now the serial output pin, or pin 9 as we want to call it, all right, this pin can be cascaded with another flip-flop where we can use it for 16-digit output. All right, however, the 7th, or the pin 9, which we refer to as Q7 not, all right, so this pin, it can be used for a serial data output as well, because just as the serial data is inputted, there's a serial data outputted. All right, so the output from this pin can allow to be moved within another shift register. All right, so that will allow the register to be cascaded and operated as a 16-bit output register. All right, so that is how we can have it work in that form. All right, so application of shift register. One is to temporarily holding data until it's ready to meet the next operation in a sequence, such as performing addition, multiplication, and subtraction. The second application comprises of register operating as a multiplexer or the multiplexer when converting data. Since data is stored or inputted using 8-bit channel from parallel data in to serial data out and vice versa, registers are perfect for encoding or decoding data. Register operate as a BCD encoder in converting binary data to read or stored as a decimal in a sequential manner. Okay guys, so this is a demonstration of the serial in parallel out register. So we use a microcontroller which allows the data to move within the register. Alright, so we use a 3 pins, use a serial in, which is a data pin, and we also use the clock pin, alright, and then the storage pin. So we manipulate those 3 pins to move the data within the registered and allow that 3 pin as it is to store that data within the output of the output pins, which is Q0 to Q7. All right, so that process is quite simple and straightforward using those 3 pin. All right, so then we use this Uno 3 Arduino or Arduino, all right, to provide the data entry to the register. All right, so that is how we're able to get it to provide the data through the output pins. All right, so from Q0 to Q7, all right, and then that value is enabled through the LED display lights. All right, so this is like the pattern of how the data is outputted from the register. Right, so if we should hold the pin steady, in chances are you'd see a certain pattern. All right, so that is done when we latch the data output. All right, so that is the simple operation of a serial in parallel out register. Okay guys, thank you for listening to our presentation. We appreciate the time that you spent with us. All right, so stay tuned for another. You may visit us at www.vigilantsocietyofengineer.com for more.